Thank you for attending our Indiana-Michigan Power webinar, Glowing Reviews, the best in energy-efficient commercial lighting. My name is Chris Guthrie, and I am the host of today's webinar. We will be sending everyone a follow-up email within the next couple of days that will include a PDF of the PowerPoint presentation materials and the playback link to the recording of today's webinar. Because of the large number of attendees, we will only be accepting written questions from you today. Please submit any questions by typing them in the chat or Q&A windows on your screen. We will take some time at the end of our presentation to answer your questions, or we will follow up with you separately after the webinar has concluded. To expand the presentation to full screen, click on the diagonal arrow icon in the top right corner of the slide. We will be conducting polls during the presentation. A polling window will appear on the bottom right of your screen, and you will be asked to answer one or more multiple choice questions. We really appreciate your participation in our polls. I'm opening our first poll now. Please be aware that you are not the only participant today. The names of other attendees are not being shown to you for reasons of privacy. Now let me introduce you to today's presenters. Mike Carter is a senior energy engineer and has a BS in engineering and MBA degree from The Ohio State University. He has worked with various EPRI centers supporting electro-technology applications and spent 10 years conducting due diligence for the technology commercialization. Mike is a certified energy manager from the Association of Energy Engineers. He writes articles for the newsletter, answers Ask an Expert inquiries, and develops webinars on energy topics. Also joining us today are subject matter experts Jason Whitman and Bob Bernacue. And with that, I'm going to turn things over to Mike to start the presentation off for us today.
Well, thank you, Chris, and welcome everyone to our fifth webinar in a fall series that we've been offering customers. We've talked about benchmarking your facility. We've reviewed ways to reduce costs in compressed air systems. We've introduced some energy-saving ideas, particularly for K-12 schools and universities. We've also introduced you to the concept of non-utility financial benefits. And today, we're going to be talking about lighting. Now, not just any lighting. We're going to be talking about the best, most efficient, and innovative lighting that's out there today. And we've sourced these ideas from several places. Recently, hundreds of companies in the lighting industry gathered in one place in Philadelphia. The scene was Light Fair International 2017. The event included about 500 exhibitors and over 25,000 lighting industry professionals, and we were some of those professionals that attended that event. We interviewed a variety of manufacturers of award-winning products. This was determined by a jury of their peers. And also, we looked at the output and awards by the Illuminating Engineering Society in what they call their annual progress report. It's published in the January edition of their magazine, LD+A magazine. That's Lighting Design and Architecture. And just took, our favorites from those that excel in either performance or aesthetics, or in some cases, both. And we're seeing some specific trends going on in the lighting industry. Color tuning is one of those trends. We'll talk about more of that in a minute. Connected lighting, meaning that lamps and fixtures are individually addressable out of the box, part of the Internet of Things trend. We're seeing lighting efficacy, which is basically the amount of lumens you get per watt of input, which is essentially sufficient lighting efficiency, continues to increase with some commercially available fixtures outputting more than 200 lumens per watt. That's a pretty good efficiency considering that incandescent bulbs output about 20 lumens per watt. So with that, we're going to take a look at, start with some just important lighting fundamentals. We're purchasing lighting today. We're going to compare LED lighting with legacy lighting. We're going to specifically talk about what lighting is available to replace legacy lighting, like incandescence and halogen and metal halide, etc. We'll look at, for indoor lighting, also we'll look at some outdoor lighting innovations and wrap up here talking about some lighting controls. So let's jump right in and talk about some very critical metrics that you need when you're purchasing lighting today. And one of those metrics is the measure of how much light is coming out of a lamp or fixture, and it's the term for that is lumens. It's something that's inherent in the lamp or fixture itself. Your distance away from that lamp or fixture doesn't change the fact that it's outputting that same amount of lumens. And just by comparison, you know, a 60-watt incandescent lamp today outputs about 850 lumens. So you really want to buy lighting based upon the lumen output, not by the wattage anymore. Then, of course, we're not only concerned about what's the power output of that light source, but how much light's actually falling on the surface. Well, it depends on the distance away from the light source. We measure that in a term called foot candles. It's something that, you know, photographers measure all the time when they pull out their light meter. And a foot candle is technically defined as 1 lumen of light distributed over a square foot of area, as shown in this diagram. Now, what's interesting is if you move twice as far away, your amount of foot candle of light isn't half as much, it's a fourth as much. So it's proportional to the inverse square of the distance. And so you have to take that into account when you choose a certain lumen source. You got to know how far away the surface is that you're lighting to determine, you know, is it lit adequately. You also might see another term in metric system called lux. It's lumens per meter instead of lumens per square foot. And you can convert from one of those to about 10 lux per 1 foot candle. There's a couple other critical metrics if you're purchasing lighting today, and they relate to the lighting quality. One of those is something called color rendering index, or CRI. It's a unit of measure on a scale of 0 to 100, and it measures the light's ability to basically render colors correctly. And so here's a high CRI color quality, 92 CRI. You can see here that whites are whites, blues are blues, and you know, greens are green. If you have low CRI color quality, like from a sodium vapor lamp, whites are kind of yellow, and wow, blues turned green, and the greens, well, they're even more green than they should be. So generally, you want to shoot for 80 CRI color quality lights and lamps and fixtures or higher. Now, this measurement uses 8 pastel colors, and if you go beyond that, there are saturated colors that you can compare light to, and the most important one prevalent today is R9, so it's one past those 8 pastel colors. It really measures the performance of the lamp to illuminate red colors, and if you want red colors to pop like retail applications, and you want to order some lamps or fixtures that have, say, a CRI of 82 and R9 of at least, say, 30 to 50%. And you'll get some real high quality of lighting. Another important metric is called color correlated temperature, CCT. It's measured in a strange unit of degrees Kelvin, and it's not the actual, you know, warm temperature of the light, but it's a measure of the tint of basically white light. And if you have low Kelvin degrees numbers, you have little orange or yellowish light. If you have high Kelvin degree numbers, anything above 4,000 degrees up to 8,000 degrees, you have kind of a blue tint to the light. It's still white light, it just has a high color temperature or low color temperature. Sunlight's right in the middle, about 5,500 degrees Kelvin. And as you purchase lighting today, you're going to hear this term about white color tuning and color tuning in general, and that's the ability of lights today to change almost really immediately from one color temperature to another, even at the same lumen output. So you might have a 1,000 lumen light source, and you can make it cooler looking or warmer looking, a snap of your fingers. That's white color tuning. Another ability is what's called dim to warm color tuning, and that's basically that when you're at a certain, say, 1,000 lumens, and you want to dim it down to, I don't know, 100 lumens, as it's dimming, you'll reduce the color temperature, make it warmer and more yellow, kind of a more ambient or warm temperature, and a lot of restaurants like to do that. That's a dim to warm capability. And then sometimes you'll even have the ability for a lamp to change its color from white to red to purple, etc. But that's really different than white color tuning and dim to warm. So it's a little confusing, I know, but just kind of keep those three straight. Now, when you're buying lamps and fixtures, you want to know, well, how long does the lamp, particularly if it's a light-emitting diode lamp, last? And well, that's kind of tough to figure for LEDs because they last so long, 50,000 to 100,000 hours. Well, that's several years, many years of operation, just burning it all the time. And so what you have to realize is that LEDs don't really die. They merely depreciate very slowly over time. So the lighting industry addressed that and came up with a concept of useful life. And so the LED is considered end of life when a noticeable depreciation of light can be seen. Typically that's about 30%. So when it dims down to about 30% of its original rated light output, that LED light is considered end of life. So how in the world then do you test or determine a rated life if it's 50,000, 100,000 hours? Well, the industry uses a couple of test data. First, they test the LED chips themselves, LED arrays, chip-on-board modules, and see how they depreciate over time, particularly at a test minimum of 6,000 hours, 3 different temperatures. But that's just the chip itself. So then they also look at, well, how does the fixture perform? And fortunately, the Underwriters Laboratory has an in situ temperature test of the fixture, and they take both of those data points and put them into a guideline, or it's called a calculation method determined by the Illuminating Engineering Society called TM21. And basically it extrapolates that 6,000 hours of testing into the 50,000 or 100,000 hours of life to determine those long-term lumens. And so you'll see life stamps on fixtures and bulbs like L70, and that L70 number might be 50,000 hours. Well, L means just that it's a lifetime, and the 70 stands for percentage of initial light. So that's your typical rating of LED life. Another term you often hear, it's again a growing trend, is human-centric lighting. According to the International Association of Lighting Designers, human-centric lighting supports health, well-being, and performance of humans by combining visual, biological, and emotional benefits of light. So we care about lighting today more than just visual acuity. We care about how it affects our circadian rhythms of our life, how awake and alert we are, our perception, productivity, our mood, etc. That's human-centric lighting. The general idea is that lights will adjust their on and off, or brightness, or colors, or color temperatures to levels that optimize any particular setting. For instance, a schoolroom or hospital ward or open office plan, they might emphasize blue hues during the morning to stimulate alertness of workers and students, and then red and orange hues might take over in the evening for more of a calming effect. Or you might have brightness levels that need to increase in a public space when more visually challenged senior citizens are there. And this little chart kind of just shows a little bit about what's happening in terms of, we're mostly focused on how efficient is the light, how many lumens we can get out per watt, and then we get into light for sustainability. Can we close the loop on the light product itself and recycle that at end of life? And now we're really looking at light for well-being, as we just talked about. A quality of life, how it affects our quality of life. That's human-centric lighting. We still care about, the sustainability of it as well, but also how it impacts our life other than visual acuity. I mentioned before, we had a whole webinar on this topic, the benefits of lighting upgrades beyond energy savings on their electric bill. That would be shown here on this energy efficiency benefits wheel. But there's other financial benefits that occur outside the utility bill, like the safety of people, so you don't have tripping or hazards bumping into things because you have better light, or better lights increasing retail revenues in a store, or better lights lowering scrap rates in manufacturing facilities, or better lights increasing productivity and those all have financial impacts on your business. There's also non-financial benefits. They don't have a direct financial impact, but they're a benefit nonetheless, like regulatory compliance. Improved lighting would enhance employee recruitment and retention. It would allow you to get a green building certification, certainly decrease your environmental footprint. So don't shortchange yourself by only considering the impact on your utility bill. Consider some of these other areas as well, some of which you can actually quantify in dollar terms. So we're talking about efficient lighting, and LEDs are one of the most efficient lights out there today. There's two types, DC LEDs, direct current, and AC LEDs. And beginning around 2005, manufacturers started offering these AC voltage LEDs. And typically they're a little different than DC because they're wired in a group in series rather than a single LED. Voltage range is a lot higher, 20 to 64 volts per LED versus 3 volts for DC LEDs. But they have some advantages, AC. There's fewer components. You can see here, very trim. You don't have a lot of capacitors that are required up here. And so you have fewer components. It means cheaper. It means more resilient, reliable. And there are some downsides, too. They've really struggled to eliminate flicker with AC because you're fluctuating the voltage all the time. Dimming is a little more challenging. Probably the best applications are one where you take advantage of the low profile of this for the most part. But you're seeing it in other places as well, like street lighting. I'll show you an example of that, where you can use AC LEDs in a retrofit case. You should be aware of the impact of heat on LEDs. All lighting produces heat. It's a myth that LEDs do not. They do. If you look at incandescents, they're basically a heat furnace with a little bit of light coming out. Compact fluorescence and other linear fluorescence, they reversed that, and it was mostly light and a little bit of heat, and most of that heat was through radiation from the light. You could put your hand near it and you could feel the heat. In LEDs, you still have that ratio, about 80% light, 20% heat, but most of the heat's conducted away. In fact, in a 77-degree ambient environment, the heat at this junction level might be about 140 degrees. And if you've ever grabbed a LED bulb in a lamp at the base, you know it's a lot hotter than ambient temperature. Typically, and if you get too hot, the output of the LED suffers. Typically, rule of thumb, anything over 110 degrees, you're going to see pretty significant decreases in light output. Now, put them out in the cold, they love that. So, put it down to 0 degrees Fahrenheit, they'll work just fine. An LED or a linear fluorescent light might not even turn on. So there's some advantages certainly in cold applications as well. Let's take a look at some specific types of lighting, and we'll start with, hey, what's available to replace incandescent A lamps? And what are some of the innovations there? Well, one of the innovations is that LEDs are mimicking incandescent A lamps, particularly the filament look. You'll see a lot of those. They're also becoming, Internet of Things enabled. This is a particular lamp that automatically adjusts color temperature due to the time of day. It'll turn on and off based upon occupancy, and it dims when natural light's present. So you don't need any light switches with these lamps. You unscrew what you've got in the ceiling, you screw those in. It communicates with this block here, and it'll operate by itself. You can, of course, program it in terms of the time of day type of things. And then, hey, if you want some tunes with your lighting, they're actually integrating JBL speakers in with LED lights. And so the center portion is going to put out some light, and then you'll have a Bluetooth-enabled speaker inside that you can cast your tunes in there through the lights in the ceiling. So a lot of innovation in replacing incandescent lamps. Second poll question today, which lighting metric changes with distance from the lamp? You got 4 choices here. We talked a little bit about that, so give your best shot, and we'll circle around and look at the results here in just a minute. You also might be looking at replacing linear fluorescent lamps with LEDs. And one of the things that's driving that is legislation. The 2014 lamp rule, which comes into effect next month, effectively eliminates F32T8s, full wattage T8 lamps, and you're going to only have reduced wattage linear fluorescent lamps available. It doesn't ban them, it just makes the performance requirements, minimum performance requirements, so onerous that only LEDs can achieve that. So if you're looking to do that, what's available out there in terms of options? Well, one of the options is you replace fluorescent lamps with LED tubes, fluorescent tubes, and the Department of Energy, through their caliper program, evaluated those. They looked at actually what the lighting facts label database reported in terms of performance, and they saw that the average TLED, we call them, LED tube lamp, averages output about 2,100 lumens. That's quite a bit more than a few years ago. It was down about 1,700. Now, a fluorescent is going to be about 2,800, but these are very directional, and so they're not putting light out, above. That's wasted. It's all going down. So that's going to work pretty well. Equal efficacy, lumens per watt is a bare fluorescent. Pretty good color rendering index, about in the 80s. Some even have 90. The cost is coming down as well. Here's some really interesting innovations here. This is the red cap. It's self-ballasted, contains space to hold components for a rechargeable battery system down here below. Here's the extra 2 prongs that charge that battery all the time. And hey, when the power goes out, then the light still is on. It emits at half brightness for about 15 minutes and tapers down the last 90 minutes. And then here's a tube with built-in wireless capability right in the tube, and it allows fine-tuning of the lamp during installation. I'll show you some other examples of that as well.
And Mike, we have the results of the poll, and if you would like to share those.
Yeah, what lighting metric changes with distance from the lamp? And you guys nailed that. Foot candles. Lumen stays the same. Color rendering index, color correlated temperature all stays the same regardless. So very good job on that. Now, if you're looking at replacing fluorescent tubes with TLEDs, then you should be aware of several different types. First, LED tubes, in this case, can bypass the fluorescent ballast with a separate DC drive installed. In that case, you get DC voltage applied to the fixture, to the tubes. Secondly, an S-type C, we call it. Secondly, some LED tubes have an internal DC drive that bypasses the ballast, again, bypass the ballast, but you're wiring the line voltage, whether it's 120, 270, whatever, right to that tube. And thirdly, you can have what's called a drop-in that operates off the existing ballast. You don't do anything other than pull the old fluorescent tube out and put the LED tube in. It has internal drivers. Of course, it'll run off that whatever voltage is typically supplied to the fluorescent tubes as well. Here's a couple of other innovations here. Like I said, this is, again, a tube that has built-in occupancy sensor at one end, and it acts as a master to a second slave tube in the fixture. So it'll just go out itself and leave the other one on. So it basically dims to, the whole fixture down half output. You can also get one that has a built-in daylight sensor. Right now you can't have both, but you can choose one or the other. And then here's a module that's using radar technology, ultra-wideband, for occupancy sensing. It's extremely sensitive, detects very small motions like hand motions, even breathing. And so you're seeing some innovation in that for lighting as well. Now, if you don't like the idea of tubes, you want to take the entire fixture out of the ceiling and replace it with an LED fixture, well, then you're looking at what we call purpose-built linear LED troffers. The Department of Energy looked at what was available today commercially and said, well, they're pretty efficient, over 100 lumens per watt, a little bit better than fluorescents. They all have pretty good color rendering index numbers in the 80s, and they have easily as much output, if not more these days, to fluorescent troffers. That wasn't the case a couple years ago, but now it is. Here's some interesting innovations here. Here's a Arches floating optic luminaire with concealed LEDs. The LED strips are right here, and they bounce the light around until it comes out very diffused. This is a LIS series from GE, and we're not endorsing any of these lights and lamps. We're calling them out by name, but they're just as an example of what's out there. There's other competitors that do the same thing, but we're just going to, we want to show you some very specific things. So this has a very high color quality. I mentioned 90 CRI with an R9 greater than 90, so you know that that makes the reds really pop. And it comes ready with daylight harvesting, motion sensing ability built in. The LEDs are in the strip here pointing upward. It bounces the light off of here out in the room so it's diffuse. And you can stack these end to end and just power several with one power cord, which is nice, makes it a little simpler. I've seen these myself in a store. It was very impressive, excellent light quality. Maybe what's going to ultimately take over is recessed linear LEDs like this. You get curved sections, straight sections, you put them in the wall, you can put them on around the window, you can put them around the doorway, however you want to light up a room. And I've seen catalogs with different applications that you can be very creative with that. Well, if you're not ready to go whole hog and take the whole fixture out, you can consider a retrofit kit. So you leave the troffer from the fluorescent in there, you gut it, everything else out of it, the driver and the tombstones, etc. And then you put in some sheet metal optics and then what we call a light engine. And those might even be built together like this one is. And you might even have a couple other little brackets you put in there to accept the LED light engine and optics. But you can get, 4,200 lumens, 3,200 lumens, 4,200 lumens out there. And it's a little bit cheaper than replacing the entire system. And if you want to even save a little bit more, you can look at what I call a strip retrofit kit versus volumetric. And here's one where you, again, gut the troffer, leave the case, put in an LED driver, hide that away back there, put in strips of LED diodes, and then cover that with a diffuser lens so you don't see the individual points of light. And if you walk up to that and look at it, you can't tell that it's not a fluorescent fixture. And there's, again, high wattage outputs available for that. You can kind of use the same theme here with signage backlighting. This company is very clever. They use those strips here and they attach them to cables. Well, the cables are the power cables. And so you can make this as long or short as you want. It's very uniformly spaced, and so it's going to light up that sign backlighting very uniformly as well. Very interesting idea, the tension LED system. When you're looking at particularly purpose-built LED fixtures, one trend these days is using light guide or edge-lit products. And so you take the panel, clear plastic or glass, you line the edges of it with LEDs pointing the light in, you frost one side or etch it to allow the light to come out, and you get light guide products. Very diffuse light, as you can see here and here and here. When you turn it off, it's actually kind of translucent. You can partially see through it, but when it's on, it's just a glowing ember here. The whole thing is glowing. There's no strips like with tubes, etc. It's really beautiful light. It has, again, a pretty high light output, very efficient as well in terms of high lumens per watt. And here's another version of that. Again, this is a suspended indirect, so you got light coming out, going down on the floor, you got light coming up in the ceiling, and you have light actually coming out on the ends going horizontal as well. All the LED strips are inside pointing outward. This is horizontal mounting. If you mounted it vertically, it looked like this. And it really throws the luminance to get vertical illumination as well as horizontal illumination. And even some manufacturers like Cooper Lighting are making troffers that you hang multiple panels on, multiple bars, and then you can swivel those here and adjust the light pattern you want on the floor. So very creative there. Here's another example of it where you can either just change the lighting in terms of grayscale, have a dappled little appearance here, and this changes every few seconds, for instance, or you can even change the light color itself and reinforce corporate identity, use saturated colors. Here's an example, again, of another trend, hybrid lighting. And so this uses both organic LED lighting. I'll explain that maybe at the end of the production here today if you're interested a little more about that. It doesn't put out a lot of light, but on the back side of this, you put strips of LED diodes pointing upward, so you can get 3,000, 4,000, 6,000 lumens going up, bouncing off for indirect light into the facility. And so this is called a duet, with the idea that it's combining OLED and LED lighting together. Now, typically you replace existing lighting, this is particularly for suspended ceilings, in the space between the runners here. But in this case, LED is so compact and lightweight, you can replace the runners themselves with lighting. And so a couple feet here of LED lighting strips, you just snip the ends, you put this in there, it's structurally rigid, and it'll output about 1,100 lumens of light per strip. You can go a little bit bigger. This is with Armstrong's particular unit. You can see it crosses several panels here, and it's a lot wider. In fact, this is made specifically for Armstrong's ceiling, which is seismic rated, by the way. And you can get some good light output from that as well. You can also combine LED lighting with recessed indirect LED lighting and LED track lighting together. That's what's shown here. Let me draw this here with my pencil. Oops, let me choose the right pencil. So here you have strips of LEDs pointing upward into this cove to bounce the light off inside and then back down, recessed there in direct lighting. And you can also, put copper bus bars along here that would power track lighting that's pointing directly down. And you can have only the recessed indirect, you can have only the track lighting on, or you can have both like shown here. You can see the track lighting kind of visibly shaded here a little bit, and adjust those however you want. Now if you want to adjust the track lighting itself, in this case you probably have to have a tool to do it, but there's products out there you can just use your hand and move it wherever you want. Or if you want to be more high-tech, this is a robotic version. It changes the rotation of the light here and the tilt of the lamp here off of your mobile device, phone, whatever, and you can reposition that any way you like at any time. We're also seeing innovation with support of daylighting, particularly traditional daylighting. You take the light in with this prism element, you bounce it around inside the tube, and you let it come out the diffuser at the bottom. This is what we're showing here for a classroom. You see the tube here as well. But what the manufacturers are now doing is they're ringing these with LED lights, and so those lights adjust with sensors to, well, how much light's coming in, because there's less in the morning, less in the evening, a lot more directly during the daytime. And in fact, the light color temperature even changes over that time. And so these LEDs will adjust that so the light coming out here is always the same level of light. It's always the same color temperature as well. We also get a question occasionally with, hey, if I use retrofit kits and I have UL listed lights to begin with, fluorescence, I retrofit them LED, is that still UL classified? Well, yes, if your retrofit kit was UL classified as well. It will have this label, UL, say classified, and it should reference that it's per the luminaire conversions retrofit, i.e. UQ standard. And it's always, of course, best to check with your authority having jurisdiction to make sure about that, but usually you can do that. Let's look at some other types of lighting. These are ubiquitous around in facilities, the MR16 multifaceted reflector lights. Again, the DOE said, hey, they're pretty efficient. You only need about 40 lumens per watt to qualify for Energy Star. The center beam, actual light coming right out of the middle onto the surface is a little less than, say, halogen lighting. And the 35-watt equivalents for LED are lots and lots of those. There's only a few that's been able to put out the same amount of light as a 50-watt equivalent halogen, which means over 500 lumens in this very small space. It's a little challenging for LEDs. They have to get in there, and it'll be there in probably another year. You'll have plenty of those. There's just a few of those available today. This particular product is called the Vivid Mosaic. It's unique in that it uses purple or violet LEDs to eliminate the blue light that some people have concerns about. In terms of other recessed downlights, this product here was voted at the Light Fair show as the most innovative product. It attaches perpendicular to the wall. There's a hidden attachment underneath, and this snaps into it. So you get downlight. You have uplight too on the other side, and even a light coming out at the end. And then I saw this product I thought was very innovative as well. It's a dome recessed in the ceiling plane, and it acts as reflectors to a hidden ring of upfiring LEDs that produce indirect light. So you can see the result of that. You can't see the LEDs, but they're firing upward here. They have very beautiful patterns on here. This is just one. It comes in 5-inch diameters, 8-inch diameters, 12-inch diameters, and it supports dim to warm color dimming as well. Another couple of products here. This is the A Pure Minus. What is it minus? It's minus size. It's very small. You see here is a penny by comparison. So if you have a hallway, maybe limited space above there, you want to upgrade to LEDs, you can put this light in. It has less than a 1/2-inch diameter outlet, but it's still going to put out over 1,000 lumens of light, LED efficient light. Or if you want to crank up the lumens, you can get over 9,000 lumens out of this fixture. It's a 6-inch fixture. Because it has so many lumens, it's going to be a little warm, and there's passive heat pipe cooling to keep that cool. Or you can go to what I call the Star Trek light here, the Green Creative's Cloud LED, but this floating, the LEDs up above here, it has some advantages. It reduces the weight of the bulb. It also helps manage heat better as well. You'd use this flipped around the other way, of course, but this is what it looks like, some innovation there as well. Try another poll question here. Which of the following is not an advantage for LEDs? We've got 5 things you can think about. Which one of these is not so much an advantage for LEDs? We'll look at the results here in just a second. And while you're doing that, I'm going to continue on. Let's look at parabolic luminized reflector or PAR lamps. LEDs are much better performance than halogen lamps. They'll use about 1/4 of the wattage to get the same amount of light. They're at least competitive with ceramic metal halide, but the analysis of these lights show that when they have that white tuning ability to change color temperature, it does degrade the efficiency or efficacy a little bit as well. This is a particular light lamp, PAR lamp, that has it all. And by that, I mean that it can change the color temperature of white light, and it can even change the color of the light from red, orange, yellow, green, blue, whatever you want. It has wireless capability built in. It's dimmable. It's, of course, individually addressable because it's wireless, and just has some tremendous flexibility built into that. Maybe if you're a museum or something like that, you constantly are changing, or retail store wanting to change the color of the light for different products, etc. Here's another light, the a BR30 lamp, and it has a unique design which allows you to put these little what they call smart snaps modules into the center of the light, this hollow here. So light comes out outside, and then this can measure either occupancy or it can even measure daylight built right into the lamp. Let's take a look at high bay lighting. These are mostly industrial fixtures, but can include street lights and canopy lights like in gas stations, etc. And they have what's personally available. It's pretty good efficiency. 2/3 of them are at least 105 lumens per watt, and 1/4 of them are 130 lumens per watt. And you're going to see here you can even get up to 200 lumens per watt, and they're pretty high output, up to 50,000 or more lumens, etc. This particular product here from Cree handles heat really well. I mentioned that the rule of thumb is don't use it in heat up to over 110. Well, a lot of high bays are hotter than that in the summer, and this will handle up to 150 degrees without any significant degradation in output, and it's still very efficient, 100 lumens per watt. Oh, by the way, they rate this at 100,000 hours, not 50,000 hours. A lot of competitors do. So, and then
I might bring up the results of the poll, and if you'd like to share those.
Yeah, which of the following is not an advantage of LEDs? And it's the hot ambient temperatures. They have a much higher rated life than its competition, handles vibration, there's no filaments involved, doesn't bother by frequent switching, and certainly it's a lot more efficient. Now, if in the high bay area, if you don't want to replace the entire fixture with a purpose built, you can just replace the lamp. Now, of course, you have that existing ballast in there. Do you need to remove that? Well, in some cases you do, some cases you don't. This is one that you use either way, actually. You can just screw it in there, take out the high pressure sodium or metal halide, and it'll sense what's available in that magnetic ballast, and it'll run just fine. And then when that ballast dies, you can just detach the wires, wire it directly to the lamp. It'll sense that it's now wired directly, and it'll work just fine. You don't use the same lamp. The original products out there, Lunaro was one of the leaders there. It had to use the existing ballast. Now, they had a certain brand for metal halide, certain brand for high pressure sodium as well. But either way you go, these work pretty well. Now, again, if you want to stay with the purpose-built fixtures, well, there's some out there that, like I said, I went to see this one at the show. It claimed 200 lumens per watt. I really couldn't believe that, but they showed me the data, the test data, and indeed, it is that efficient. I like this one too because it's very rugged. It's a die-cast type of a housing. I call that being built like a tank, and it really is. And then there's others, several out there like this that have both uplight and then the downlight. You can't see it. That's underneath there that for high bay type lighting. That's pretty representative of that. And again, you can get 68,000 lumens up to 34,000 lumens, 24,000 lumens, pretty high lumen output with all of these lights. If you go outdoors, what's available there? Well, LEDs are attractive for a couple reasons. One is they have a higher quality of light. Here's a parking lot. I mean, which kind of light would you like? Your yellow car sitting here is going to look white. It's going to look yellow here. That's very uniform lighting. You can see there's hot spots under the high-intensity discharge lighting. You can see, again, the difference in outdoor street here, exactly the same, only they replaced it with LEDs. And because the light quality is so much better, you can cut the lumen output by at least 30%, maybe 50%. And generally, they eliminate light pollution. A lot of them are dark skies compliant, something to look for as well. A couple of other interesting developments here. This is a product on the left here that is a surveillance platform, and it has an active deterrence mode in which it will flash the lights and create audible messaging when motion is detected. So this will talk to you and flash and warn you to leave the area. And this one here, well, imagine if your living room floor lamp was made 10 times larger for outdoor area lighting, and that's what this really is. Poles are up to 35 feet tall. They can accommodate up to 5 of these teardrop-shaped luminaires that each provide about 5,600 lumens of light output. And you can also integrate on the pole Wi-Fi, audio, or CCT camera capability as well. Very interesting designs. If you have legacy street lighting and you want to make them a little smarter, you want to be able to measure energy consumption, then you can use these little bullets, they call them, from WattStopper. It has a standard connection, put it right on top of the existing legacy light, and it gives you a wireless mesh network and real-time energy monitoring capability. Here's an example of using AC LEDs because they're so low profile. You just take a shoebox that has, I don't know, an HID light in it, has the lamp holder, has the ballast, just leave them all in there, and then put this custom cover over the top of all that with the LED lights, and away you go. And so it's somewhat limited in lumens, but it's very efficient, and there's no driver involved. It's typical of AC LEDs. We're seeing the light guide or edge lit lighting solve a lot of glare problems in parking garages. You're seeing a lot of those products. This is a TechDex version of that. This is a Cree's version of that. This is Philips' version of that. They're all using that light guide, glowing plates of light. This one has some uplight as well to be not only efficient but and high color quality, but not be a glare problem as well. If you're looking at outdoor sports lighting, well, you're going to need a lot of lumens, a lot of light power. And so, well, here's 84,000 lumens or 168,000 lumens out of this big boy, 83,000 lumens here. And so there's plenty of light for LEDs, very efficient, pretty good color quality as well, products out there today. Last poll for the day, would you like someone from the utility company to contact you about lighting upgrades in your facility? Let us know if you'd like some help there. And then how valuable has this webinar been to you? And there's several choices there. So just as we wrap up, just wanted to mention briefly some innovations in retail lighting. We're really seeing light and data converge to create a rewarding customer experience with what's called visible light communication. In this case, the LED lights are pulsing at a very high frequency. It's not noticeable to the human eye, but it can be picked up by your smartphone camera, and it will be able to track you through the store, and it'll tell you, hey, if you're looking for shoes, you're starting here, here's a path to get there to the shoe department. And as you're walking along, it'll know that you're by the coat department or when you get to the shoe department, and it'll send you some coupons that's applicable to where you're standing. Of course, because it's tracking you, that tracking data can be mined to optimize aisleways and product placement, et cetera. Target Stores is one that's been a leader in this. This is augmented by Bluetooth wireless as well, and Target actually, it's actually a little unknown yet. It looks like they're primarily relying on Bluetooth wireless because one of the problems with this is, well, if you're trying to save energy and you need the lights on for the service, well, you can't dim them or turn them off so easily. So, but you are seeing it being used. The last two things are, hey, since LED lights are so energy efficient, they have so low wattage, hey, we control them with Cat5 internet cable communications. Let's send the power over that as well, and that's what's happening with power over Ethernet. You can see here you get a power supply, a driver, a hub. You put the snap the internet cable to those. You don't need an electrician, and then you can individually control each light independently, and you know, use DC power that it needs anyway, rather than running AC all the way to the lamps. Another variation on that theme is called distributed low voltage power, and it handles a lot higher wattage lights. And it can also be daisy chained, and so each of these DLVP compatible lights fixtures have dip switches on them, and you can set them to zone 1, 2, 3, or 4, and then the controller will know and send out signals to zone 1, zone 2, whatever, to do whatever it needs to do in terms of dimming or turning on, off, etc. So that's another variation on the theme. If you're looking at lighting in a municipality, street lighting in general, just one last word on that. Well, network street lights now have the ability to do things other than just create, visibility. It can direct drivers to available spaces. It can give warnings in the event of a hurricane, or you might have a public address speaker concealed within a light post. They can give emergency responders, say with a camera on it, views of an area as they're responding to a 911 call. And even cities like Los Angeles is testing sensors attached to streetlights to wirelessly detect gunshots and other noises and triangulate those so they know exactly where the location is that gunshot noise originated from. It can send early responders to that area. So it can track asset management. Hey, there's our trash bins or whatever on the street. If they're moved, they will know that. You can track trash trucks doing their job or whatever from the city. So a lot more than just illumination these days. I'm going to leave you here with some resources. This is the resource for looking at a lot of those product evaluations I just mentioned. This is the list of products that won awards by jury of their peers, and this is the progress report source here. You got to really get that issue of the magazine. You can't really find it on LD+A's or the other websites there. So with that, I'm going to turn it back to Jason Whitman, who's going to supply some information on the utilities energy efficiency programs.
Terrific. Thank you, Mike. Well, this was our final webinar in our series that we've hosted, and we just want to say on behalf of Indiana Michigan Power and our energy efficiency team, thank you to Mike for a terrific job you've done. I hope some of you have been able to participate in some of our other webinars as well, and you'll agree with me that he's done a great job presenting some good information. And you know, that's our goal, was to present to you, our customers, our trade allies, or if you're an energy professional as well, just some information, maybe something interesting, or to educate you about what's out there, and maybe hopefully improve maybe the service you provide to your own customers, and in turn provide better products and a more educated environment to do so. So again, thank you, Mike, for your terrific presentations. So as I mentioned, our goal was really to educate and inform you, but also to drive you and your prospective customers to our energy efficiency programs. And you see what's listed here is our 2017 offerings, and we are going to have similar programs in 2018 with similar incentives and rebates. So not a lot of changes there in Michigan, but we do offer a prescriptive program. It's really a one-for-one kind of an option. If a customer or is looking to replace lighting, for example, since that's what we talked about today, on a one-for-one basis, our prescriptive program would take care of them there. And we've got different programs designed to be flexible to take care of your needs as a customer. So we have our custom and our new construction, and also our small business direct install program. So we encourage you to participate. My contact is listed here, my phone number, my email address, but also you'll notice we have electricideas.com/work, and this is the website where we host all of our program information. You're able to download the application. We have plenty of resources there, our Trade Ally Network. So really it's a site that we host a lot of our program information, as well as in addition to getting a hold of me if you need anything specific. So I hope you found this beneficial. I do want to say that in 2018 as well, we are going to be offering an audit tool library. This will be a series of tools that you can loan from us here at Indiana Michigan Power. You contact me to do so. So we'll be offering an ultrasonic air leak detector, a light meter. We've got a 3-phase electrical energy logger, a thermal imaging camera, a fluorescent light tester, and remote display clamp meter as well. So several good tools that you can use, maybe do some testing and determine your energy needs at your facility, and we'll be glad to deliver those to you and let you use those at your leisure as well. So I hope you found today's webinar beneficial. Again, my contact information is listed here, my phone number, my email address. Please feel free to reach out to me. I'll do my best to meet your needs and support your energy efficiency projects as well. And having said that, again, thanks for participating. I'll turn it back over to Mike, and we'll go from there. Thank you.
Well, thanks, Jason. And if you have any questions, type those in the Q&A text box. We're happy to answer those. Let me take a look here. There's one question about the difference between OLEDs and LEDs, and I think I illustrated that just very briefly on this slide here. Yeah. So you can see here that you have these glowing rectangular panes of OLEDs here, strips of OLEDs. OLEDs are, again, organic light-emitting diodes. So they are kind of LEDs, but they're not little point lights. They're a multi-layered product, 12, 15 layers of different chemicals, et cetera, that make the strip glow. You can cut the strip, in half or in different designs, and the whole thing will just glow as long as you supply power to it. It is typically high power, regular voltage, AC voltage applied to that. They don't put out a lot of light per area, per square foot, so they're pretty dim. So they're not really light I call them, they're lights to be seen but not to see by. They're very expensive still. They're not very efficient in terms of lumens per watt, on the order of 40, 50 lumens per watt. They are trying to increase that. They've had claims that are much higher than that, but the actual fact is they just haven't. But for aesthetic reasons like this, I mean, this is a beautiful looking thing. It's flexible and bendable, so you have a lot of leeway to design some beautiful lighting with that. If you put enough of them up there, you can get some significant light. But the advent of edge-lit LEDs or light guide products that I mentioned before mimic this same effect these days, a lot cheaper and a lot more efficient, like this and this. And so OLEDs are really now, if you're looking at the Christmas ads, they're primarily penetrating the television marketplace for high-quality television, not so much for illumination purposes. So that's kind of the general differences between those. Let's see if any other questions here. Okay, question about purchasing. How do you know if the manufacturer of those LEDs is a reliable manufacturer? There's been problems in the past with some low volume, low-cost products coming from overseas not being as good quality. Let me share just the top manufacturers today of LEDs. The number one is Nichia, N-I-C-H-I-A, out of Japan. Osram Opto out of Germany. There's Lumileds in the U.S., one of the rare U.S. manufacturers. Seoul Semiconductors out of South Korea, and Samsung out of South Korea are probably the top 5. There's other high-quality manufacturers, Cree, LG in the U.S., LG Innotek out of South Korea, Everlight out of Taiwan. And if you find those products, particularly the first top 5, you're going to be pretty sure that you have pretty high-quality LEDs. So it's certainly something worth investigating. Let me see. I don't see any other questions, and we just have a couple minutes left. So I'm going to go ahead and turn it over back to Chris for some closing comments. Thank you for your attendance and participation today.
Well, thank you, Mike. I would like to thank you all for attending our webinar today. As a reminder, the presentation materials and the playback link to the recording of today's webinar will be emailed to you sometime within the next couple of days. If you have any additional questions or feedback, please do not hesitate to contact us. Thank you again for attending, and have a great day, everyone.